Hi, my excellent fifth grade math teachers. I'm so excited that you're here today to find out a little bit more about the math content of the week of October 3rd through the 7th. I'm Sherry Height, and I am your math facilitator for grades 3 through 5. And what that means is anytime you can't find something, a link is broken, you have a question, you need some support in planning, or maybe you're missing some math manipulatives, anything like that, you can always reach out to me at extension 28705. Or you can give me an email, send me an email at slheight@mesquiteisd.org, and I'll do my best that I can to support you, get you what you need, or at least point you in the right direction for what you need. And if all else fails, let you borrow something of mine. Okay, so I'm always happy to help, and I'm super excited that you're here with Mesquite ISD. All right, so let's jump right into this week of October 3rd through the 7th. I'm really glad that you're here today for this DCP week, especially if you're new, because I did want to talk a little bit about the flex days for DCPs, something I've been wanting to share with teachers for years. So we all know that even though I have the flex day on the Friday, if your campus tests on the Tuesday, you're just going to move this flex day to Tuesday and push everything back one day. And the beauty of that is, I don't want you to worry. I'm not testing anything from this week on your DCP number 1. All of this will be tested on DCP number 2. The other thing I've added this year, because the last few years we've had COVID days and snow days, and it has just really messed everything up to where there are things that have been on the test that we haven't gotten to teach yet just because we hadn't been in school for those days. And so this year, I'm also not testing anything that you have just started the week before the DCP. So the week prior and the week of, those things will not be on your DCP. I don't think it's fair to students to test them on something you haven't had a chance to teach yet. And so just on the off chance that we have some crazy days like we have had in the last few years, I just wanted to take that completely out of the equation. And I really hope that that helps you. So let's look at Monday. Monday is a continuation from last week's lesson of adding and subtracting decimals. Ryan Castle talked to you about this in the video last week a little bit, so I'm not going to harp on this subject for too long. And then we'll get into 5.3D because it's taught a little bit differently than at least the way I learned it in school, maybe the way you learned it in school. But let's start off with 5.3K. Add and subtract positive rational numbers fluently. Now, this has been tested 10 times in 5 years, which tells me it's tested twice a year, right? So this is a heavy hitter. Now, it's been tested with whole numbers and decimals 4 of those times. And that's a pretty big number compared to everything else. We've had it, 2-step problems have been tested 3 times within this category, and it's been tested with a fraction and a decimal 1 time. I think it's actually been tested 2 times, but maybe not just in the last few years. And so I don't want you to worry about adding and subtracting a fraction and decimal right now. We'll get into that a little bit more when we learn about fractions. But if you did want to front load a little bit of that, since we are talking about decimals, and when we see 9/10 as a fraction, just saying it out loud, we can very easily write 9/10 as a decimal and add it to 6/10 as another decimal, just keeping them the same. But don't fear, because it won't be on your next DCP. It'll be after we teach fractions, okay? So don't pull your hair out about it or worry about it too much at this point, but never hurts to front load a little bit, does it? It's also been tested where we've added 3 numbers 1 time, and then 1 time there was a not here question. Don't we love those? Not here. And so if a student's a little bit off, they choose the not here. And so that's 5.3K, which we're finishing up on Monday. And then 5.3D is a supporting standard. It's been tested 3 times in 5 years, so not tested as often as 5.3K, but for a supporting standard, that's quite a bit that it's been tested. And here's the big verb in this TEK: represent. Represent multiplication of decimals with products to the hundredths using objects, pictorial models, including area models. And so this is not multiplying with decimals. We're not there yet. This TEK is simply representing. And so for me, I was never taught how to multiply decimals and whole numbers or decimals to the hundredths with representing with a picture or objects at all. And so I'll show you a little bit of that later on in the video. All right, so I do want to just real quickly go over 5.3K. Last week, Ryan showed you a few examples of adding a whole number and a decimal or subtracting a whole number and a decimal. I know he definitely did one subtraction one because it was across zeros, yuck. But I wanted you to see that there are more examples of whole numbers and decimals. And this is what we want you doing in the pre-planning, is looking at, oh my goodness, it's been tested this way 4 times, so I might want to pay attention and make sure my resources have whole numbers and decimals with adding and subtracting. I want to make sure some of them are 2-step. That's the whole point in going through these IQ release questions, is to see, okay, how is it tested most often? Is this tested more frequently than other TEKs? Things like that. So looking at this one, there's a very specific reason I chose this question. Last month, Jim drove his car 2,718 and 3/10 miles. That's a lot for 1 month, isn't it? That brought the car's total mileage to 87,416 miles. What was the car's total mileage before last month? Okay, so what I want to hit on this time is, what operation would this be? So how do we get kids to not just number pick and add everything together? It seems to be a problem as I go walk classrooms, and I even remember from teaching, they just want to number pick. And you'll notice in this one, this problem, that the word total is in this problem twice. And what do most kids think total means? They think, oh, that means we're going to add these two. But if we actually take the time to make a strip diagram or some other kind of visual, what we'll notice is that the total miles that the car has been brought to is 87,416. And just like in a part whole math that they've been learning since kindergarten, we know that if we know the whole, the total, then that goes right here in the top or just all the way across. Every once in a while, they'll show it at the bottom instead, but it goes all the way across. We know the total miles. We know that the miles driven last month were 2,718 and 3/10. But what the question is asking is, what was the car's total mileage before last month? So we know what the car's total mileage is now, but we don't know what it was before this almost 3,000 miles right here, right? So there's a missing part. And they've been learning since at least first grade that if we know the total and there's a missing part, that means we're going to subtract, because we're trying to figure out what the total miles were before he drove the almost 3,000 miles. And so, I'm saying the almost 3,000 miles. What I'm trying to get you to start thinking about is having your kids have those math talks, those talk moves about, should our answer be more than 87,000 miles or less than 87,000 miles when we're done? If this is the total now, and we want to know what the total was before he drove these miles, what should our answer be? Should it be higher than 87,000 or lower? Well, it should be lower, right? So right away, I can get rid of answer choice C and answer choice D, because I know I'm going to subtract and my answer should be lower. And let's get in that reasonableness. This is 87,000 miles. This is about 3,000 miles. So I'm thinking my total miles before that are going to be about 3,000 miles less than this right here. So maybe somewhere around 84,000. And look, both of those choices are pretty close, right? So again, this is why we don't teach keywords. If we teach that total always means add, and they get a question like this with the word total in there twice, they're going to just add these two numbers together, right? And they're going to come up with one of these other answer choices. So we've got to make sure that we stay away from teaching those keywords. So Just like last week where Ryan was showing you, when we have a whole number and a decimal, that whole number has a decimal at the very end of it. It's just hiding. And so when we are subtracting a decimal or adding a decimal to a whole number, we have to add in that hiding number and then the hiding decimal and then the trailing zero so that we can line up those place value positions, right? And so now when we subtract, look what we get. 84,697 and 7/10 miles. And is that lower than this? Is it about 3,000 lower than this? Yes, it is. So our answer is reasonable. And so we actually have answer choice A as the correct answer. But you can see where it could totally go wrong if we're teaching keywords, right? So these visuals of strip diagrams, which they hit really hard and heavy in 4th grade, should really help your students in choosing what operation to use. And so that's all I'm going to talk about 5.3K since Ryan hit that really well last week. So 5.3D, represent multiplication of decimals with products to the hundredths using objects and pictorial models, including area models. Now, one thing I've learned about STAR in 4th and 5th grade is they like to change the whole on us a lot. You'll notice that here it's showing the whole is the flat. And so a whole flat, all 100 little units equals $1, okay? But sometimes your whole will be one of these, but it always is at least gonna tell you what the whole is. So in this problem, George bought 3 peppers for a cost of 40 cents each. The model represents this situation, and you can see 1, 2, 3 peppers. Each pepper is 40 cents each. That looks like 4/10 or 40 hundredths. Remember, those are equivalent. Just another time where you can point that out to students that 4/10 is the same as 40 hundredths. And so the question asks, which equation shows how to find the total cost in dollars and cents for the peppers George bought for all 3 peppers? Now, right here, 3 times 4 equals 12. That is a misconception because in 3rd grade, this was 3 groups of 4 or 40. 3 groups of 40. So we've got 3 groups of 40 equals 120. Well, does it even make sense that if he bought 3 peppers for 40 cents each, that we would be spending $120? Again, that talk of reasonableness. Let's look at this one. 3 times 40 cents each. Isn't that what we're doing? 3 groups of 40 cents each equals $1.20. Well, let's see. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, or one whole dollar, and 10, 20 cents. So this one, this H looks like that's the correct answer, but let's look at this one too. This one has the same exact numbers, 3 times 40 cents or 40 hundredths, but it says it equals 12 cents. Again, that reasonableness. Does it make sense if we're paying 40 cents for each of the peppers that our total cost would be 12 cents? That doesn't really make sense, does it? And so having those conversations about reasonableness is imperative. So here's another one. Remember I told you that they like to change the whole on us, don't they? In 2016, Marcella used this model to represent one whole. And so now we have one of the rods is a whole. Okay, so this is like the whole. All right, so which model represents 1 8/10 times 4, or 1 8/10 4 times, okay? So this one has 1 8/10 plus, well, 4 hundredths. Not quite, right? This one has 1 8/10 plus, 4/10 or 40 hundredths. This one has 1 8/10 one time, 1 8/10 two times, 1 8/10 three times, 1 8/10 four times. That looks like that's probably going to be our answer choice. This one, 1 8/10, but I think that looks like they might be dividing it up by 4 in that case, and not quite dividing it up evenly either. So H would be our answer on that. So what I have started with is just the whole number times a decimal. Now we're going to get into a decimal times a decimal in a moment. But what I wanted to show you before we go on to those IQ released items is our resources that are in curriculum. So in curriculum, so much of the time, like almost every lesson, you're going to get your teach piece from this book right here, Math and Practice, this big orange spiral book. So if you don't have this book, you need to be asking people on your campus, hey, let's look and see if we can find this book. Someone may have taught math in the past, or maybe their room was used for 5th grade math in the past, and it's just in somebody's cabinet. So something really important to look for. Unfortunately, we don't have any extras of it in the office anymore. I've given out every single one I have that I had that was extra. And so if you don't have it, your principal can order it for you since it's in curriculum. And if you need ordering information, you just let me know and I will send that on to you or the secretary or whoever. But it is a very important resource in the math curriculum. We use it all the time. One of the things I love about this resource is even though we're using models and we're kind of learning a skill here, we're doing it in the context of a word problem. And so this comes straight from Math and Practice. It starts off with this word problem. The candy store is selling chocolates for 23 cents each. Sonia bought 8 chocolates for her friends. How much did Sonia spend on chocolates for her friends? And so you see 10, 20, 1, 2, 3, 23 cents. 23 cents. Oh, there's the 3rd friend, the 4th friend, the 5th friend, 6, 7, 8. So we have 23 hundredths 8 times. And then when we put them all together and we count them, we end up with a whole and 84 hundredths. And so how much did Sonia spend on all of her 8 friends for the chocolates? She spent $1.84. So we just kind of count all of that together. Just push all the 10s together and make a whole, and then count the leftovers for that 84 cents. And does that make sense? Because we have 20, 40, 60, 80, 100, 20, 40, 60, and then the rest of it comes up to the 84 extra cents. Okay, so again, that reasonableness. So that's how we start in the curriculum. We start with the actual manipulatives, which is how we're supposed to start. We're supposed to start with manipulatives, then move to the pictorial, and then go on to the actual questions. That would be like STAR. So one of the other great things in curriculum for this particular part of this TEK is we have some multiplication matchup cards in curriculum. And so what you'll do is you'll make a copy of this for every pair of students, cut them up and mix them up and put them in bags, and the pairs have to talk through how to match the equation to the pictorial. And some of them look kind of funny, like this one is not too bad because you see 1, 2, 3, 4, 5, 6, 7 tenths. And then you see another 7 tenths, but it's partly here and partly here. And then you see another 7 tenths. But what you see when you put them all together is I have 1 whole, I have 2 wholes, and 1 tenth. So see how it matches this perfectly. Okay. And then this one, you have 19 hundredths 4 times. And so it ends up looking kind of funny. But anyway. It's kind of a fun little matching game. It's very pretty, of course, and it really helps them with the representing piece, making sure we can represent the pictorial and the equation and be able to see how they belong together, and also that our product is correct. Okay, so that is in there as well. All right, in Math and Practice, there is also a number talk, like a number string to kind of help with this concept. And so basically you just write these on the board somewhere and ask students, what do you notice about the placement of the decimal in this number string? So this is after we've practiced with the base 10 blocks and the pictorials, and now we're looking at decimal placement. And we're seeing, do we notice any patterns? Okay, what we're trying to get students to do is discover the rule for where we put the decimal placement when we multiply. Okay, and so hopefully this little talk between the students will help. And we just remember that math is all about patterns, and that was straight from Math and Practice. But since math is all about patterns, a lot of times it's discovering rules through those patterns. Okay, So now we're going to work on multiplying a decimal by a decimal. And this lesson begins in Math and Practice on pages 129 and 30. It's really important for students to make sense of the notion that when you're multiplying two decimals that are less than 1, that it will result in a product less than either one of the factors, because we're multiplying something less than one time, if that makes any sense. And so we're going to see how that looks in Math and Practice. So for example, if we have 6/10 times 5/10, or 60/100 times 50/100, either way, right? They're the same. Will our product be less than the factors? And explain. It's a great time to have some turn and talks and just see if we've got some reasoning there before we even start. What would an area model for this multiplication problem look like? And I know some of you are like, wait a minute, area model, we haven't really done area this year, but students have been working on area since 2nd grade. And so we actually can talk about an area model, and that's exactly where we're going to go with this. So in order to solve this problem, these are our steps and that we can put in our journal. The first thing you're going to do is color the first factor vertically. And so 6/10, we're going to color in 6/10 vertically, or 60/100, it's the same because this is 1/10, but it's also 10/100, right? So that's our first step. Our next step is we're going to color in 5/10 horizontally. So we're going to go 1, 2, 3, 4, 5/10, color them in horizontally, okay? And then here's how you find your product. The product is when you count the overlapping squares. See this? It's darker because it's got the green and the pink. That is your product, okay? And so when we count those squares, it's 1, 2, 3, 4, 5, 5/100. Well, then that would be 10, 15, 20, 25, 30, 30/100. But we could also get rid of this 0 and call it 3/10, couldn't we? It's the same thing, right? And so that's how you find your product of a decimal and a decimal with representation. So now that we looked at how to teach it, because I know many of you probably haven't taught it that way before, especially if you're new, now let's look at what the IQ released items look like. So remember, we're representing multiplication of decimals with products to the hundredths using objects and pictorial models, including area models. So this time, the flat represents the whole. And so which model then represents 9/10 times 4/10 and equals 36/100? Well, remember, we would color in 9/10 all the way down and then 4/10. And does this look like 36/100? That looks like 9, 10, 11, 12/100. So that can't be our answer. Okay, so let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9/10 vertically. Do we have 4/10 horizontally? And then see where they overlap is the really dark shaded. And I see 4, and I see 4/100. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I know 9 times 4 is 36. But if I don't know that, I can count each of these individual squares and go 4, 8, 9, 10, 11, 12 until I get to 36/100. And I can see that H is the answer, but let's just check. This is 3/10. They're all vertical. There's no overlapping, so that can't be my answer. And same for this one. So my answer is H. Okay? Now, here's another one. This one, I'll tell you what threw kids off with this one. It was remembering that we know that tenths and hundredths, if I have 8/10, it's also the same as or equivalent to 80/100. And so for this one, they did it backwards of how we're showing them, but remember, whether we multiply 8/10 first or 4/10 first, it doesn't really matter. So what they did is they did 4/10 vertically, and then they did 8/10 horizontally, And then the product, again, is going to be the really dark squares. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 4 times. So that should be 32 hundredths should be our answer. Well, if you notice, that's definitely not right. 80 times 40. No, we're talking about decimals here, so that's not right. And then we have 2 that show 32 hundredths, and then this distractor of 32 thousandths. Remember, we're only going to the hundredths. That's what the TEK says. We're representing multiplication of decimals with products to the hundredths, first of all. So it has to be one of these. So now we have to figure out, is this equivalent to 8 tenths and 4 tenths? No, that's 8 hundredths and 4 hundredths. This, however, is 8 tenths or 80 hundredths and 4 tenths. So C would be our answer. Okay, so that's a little bit trickier. But what I want you to for sure know, one more thing. Just that 8 tenths is equivalent to 80 hundredths. Okay, so I'm actually not going to play this video, but what I wanted you to know for your pre-planning, before you meet with your teams, if you are seeing something in curriculum and you're like, I have never seen this before. Like this, I feel like is one of those things where we're like, I've never seen this before. Well, slide 2 in your Google Slides for almost every lesson has a video to show you how to teach it. And so this video came directly from our Google Slides for that day that we're teaching this. And it shows you exactly how to do 2 tenths times 4 tenths and what it equals. Okay. And so what's great about this is you can always pause these and go, what in the world? And try it out on your own and rewind if you need to. But these will always be on slide 2. Almost every lesson on slide 2 is how to teach it. Okay. And hopefully that helps, especially if you're new to math content or new to the grade level. All right. And so this week, our office hours will be on Tuesday, September 27th from 3:30 to 4. If you have any questions regarding anything in curriculum, please feel free to give us a call. We're here. We're happy to help. And we would really enjoy the questions. And then please fill out this survey using the link or the QR code. This will help us know that you watched and help us serve you better in the future. Let us know what you're thinking, if the videos are being helpful, if there's something else that would be helpful to you in the planning process. Our main goal through this is to show you these are the things that we would love for you to be doing in your pre-planning so that when you get to your PLC, you can get the things done that need to be done and actually in your lesson plans before you leave for that day. And so that pre-planning really helps make things go a little bit smoother and quicker. So we're happy to hear your feedback. We love feedback. You may have noticed I've put some feedback in your scope and sequences, and I really want to hear from you because by the time we get to spring and we meet with curriculum writing teams, we sometimes forget, okay, did this go well? Did this go well? Did we need more time on this? And so I would love for you to be sending me that feedback so that I can help you, I can help make things better and easier for you, because that's my goal, is to support you and make your job easier. Again, if you need anything from me, SL Height 28705. Thanks for stopping by.